Now we know that the store sold 600 caps at $15 each, and the store would like to, increase his revenue, and he knows that for every $1.50 increase in price, he will sell 30 fewer caps. So on the one hand, it works to his favor because the more I increase the price by, the more I'll get per cap, but by the same token, the more I increase the price by, the fewer I'll sell. So let's take a look at this example one step at a time. Now the original revenue is just the number of caps I sell by the price. So if I zoom in over here, my original revenue is just going to be 600 times 15, which gives me 9,000. Now what happens when I increase the price by $1.50? So no longer do I have 600 caps, but I'm going to be decreasing the number of caps I sell by 30, because for every $1.50 increase, I subtract 30 from the number I sell. And like I said, I'm increasing the price by $1.50. If I do this math, what I end up with is 570 times 1650, and that gives me $9,405. So that's a good sign. I mean, although I'm charging a little bit more for the baseball cap, I'm still making more. In fact, from the revenue point of view, I'm making just over $400 more than if I had charged $15. But what if I increase it by $1.50 again? Well, in that case, the number of caps I sell will go down another 30. So instead of 600 minus 30, we're going to have 600 minus 60. And instead of $1.50 added to 15, I'm going to be adding $3 because it's $1.50 twice. And what this ends up being is 540 actually. 540 times 18, which gives me 9,720. So that's good. I mean, I'm still increasing the price. I'm still increasing my revenue. So this looks like it's a good thing. Let's do it again another time. So in this case, I'm decreasing the number of hats I sell by 90. And I'm increasing the price by $4.50, which gives me 9,945. I'll skip the middle step in between. And again, this looks good. So what are the variables in my scenario here? Well, the obvious one is the revenue, which I'll write in over here. So I have revenue. And the other one is, well, is what X stands for, and that is the number of price increases. And we'll put that over there. Okay, so in order to maximize my revenue, I need to, I need to figure out what my maximum is going to be. Maximizing revenue means finding the max. So let's begin by defining some variables. So the variables are pretty much defined by what we're looking at, the revenue and the number of price increases. So I'm going to write that over here. So let's say R, let R represent the revenue. And let X represent, and this is the harder of the two variables to kind of grasp, the number of price increases by $1.50. So these are our variables. R represents the number, or R represents the revenue, and X represents the number of price increases by $1.50. Let's see if we can come up with an equation in factored form. And all I'm using is the model that I've used above, but I'm going to generalize it. So watch closely. So I have my revenue R, And I know that if I sell the caps at 600, sorry, if I sell the caps at $15, I sell 600 caps. But every time I increase the price by a multiple of $1.50, I decrease, in other words, I subtract the number of caps sold by multiples of 30. And that's our equation. Okay, this is our factored form of an equation, which what we're going to do now is expand it, collect like terms, and write it in standard form. And you're going to see where this is going shortly. So I'm going to multiply this times this and this times this. So let's see, what do we get here? We get 9,000 plus, let's see here, 600 times 1.5 gives me 900x, minus 30 times 15 is 450x, and finally negative 30 times 1.5 is negative 45, and that's x squared. So I'm going to collect my like terms together and put them in decreasing order of powers. So this is my first one. There's nothing common with that. The two terms in the middle, well, the positive and negative 450, sorry, the positive 900, negative 450 gives me positive 450x. And finally, that 9,000, I can take this, copy it, and just place it at the end here. So there's your equation in standard form. Okay. So let's move on. We want the maximum revenue. Now we know this is an equation of a parabola and it opens downwards. So if I look at just a rough sketch of the graph, it's going to be something like this. Remember, the y-axis is revenue and the x-axis is the number of price increases. What I want to figure out is, what is this point here? Again, this is a crucial point because as a store owner, okay, look, we're increasing the price, so we're on the up. But if I increase the price too much, well, what happens? Less people are going to want to buy this baseball cap, and my revenue starts going on a downward trend. So that's what we don't want. We don't want to have that. We want to either be increasing our revenue and ideally maximizing our revenue. That's where we want to be, at the very, very top. So how do we find the maximum value? Well, that process is called completing the square. And what we're going to do is we're going to rewrite our equation from standard form. So let me just copy this here into vertex form. So bear with me. One step at a time, we're going to transform this equation here. So this is a quadratic with an a value of negative 45, which is different from 1. So I'm using my second technique. So I have negative 45, so I'm going to factor out from the first two terms. I get minus 10x and then plus 9,000. Then off to the side, I'm taking that negative 10, dividing it by 2, which gives me negative 5, taking that number, negative 5, squaring it, and that gives me 25. So this 25, let me just move this work over here. This 25 is what I'm going to add and subtract inside my equation. So I have negative 45 x squared minus 10x plus 25 minus 25, close bracket, plus 9,000. So I'm doing well here, I'm almost done. This trinomial is always going to be a perfect square trinomial, so I can rewrite it as x minus 5 squared. And this last term, the negative 25, before I take it outside the bracket, I have to multiply it by the 45. The negative 45, that is. So negative 45 times negative 25, and then it will come outside the bracket. That gives me 1,125 plus 9,000, which equals negative 45 x minus 5 squared plus 10,000, 125. So going back to the original question, what did it ask for? The maximum revenue. In other words, what's going to be my maximum revenue in this case? Well, this is our final answer here in vertex form. If you notice that the vertex can be derived from these two values. In this case, it's going to be 5, 10,125. There's my vertex, and in my parabola, this is that top point up there. Just shrink it a bit and move in here. And so what I get, let me take apart this vertex, is that when x is equal to 5, my maximum value is 10,125, which is where I want to be.